Alright, hello my wonderful students. This is foldable number 3 of section 4.4, finding the real roots by graphing. At least the top part is. The second one is going to be an error analysis. So we're going to zoom in here. Alright, so what are the real solutions of the equation? And so we're going to use two methods. And our first method we're going to use is just to be plugging in the two equations here. So we're going to go ahead and go to our add graph. I think I already have one on here. Nope, brand new, fresh, perfect. So we're going to go ahead and add our first one. We have our cubed plus our 5, and enter. It's going to put our first graph up. Then if you push tab, it'll open up to put a second graph up, F2. So that's going to be our 4x squared plus our x, enter. And these are the two graphs that comes up. We're going to kind of like, if you see the little hand pop up next to the axis, click on it. Or not. Well, whatever. So what we're going to do is we're going to go, because you should be able to, well, let me get out of this. You should be able to grab it. There you go. And move it down slightly. I don't think it worked. Alright, so that's good right there. So we're going to go to menu, trace. Oh no, sorry, not trace. Go back. Back. We're going to go to analyze graph. We're going to go to intersections. And we're just going to choose just outside the boundary of each one. Like that. And then there should be two intersections. Let me zoom in so you guys can see the ones real quick. Alright, zoomed in. So we can see two of them right now. We see x is 109 or negative 109. So method 1, let me move this to the side. Well, I can actually put it here and let me just move to the side so I can write. So method 1, which is this one, putting the two graphs together just like that, is going to give me our x of negative 109 or 1.09. And we're going to get the other one of 1.16. But there's another one that's like way up there. It's like too crazy high to kind of figure out. But I know it's actually at 3.93 because I followed it up before I did this. But if we try to do it, like we go to trace graph, and we try to go all the way to 3.93, it just takes so long. So just take my word for it that it's there. So that's method 1. Method 2. Is the one I kind of showed you in class. What you can do is you can take this equation we have with x cubed plus 5 equals to 4x squared plus x, and then subtract everything over to the left side. So we subtract 4x squared, subtract 4x squared, we get x cubed minus 4x squared plus 5 equals x. These subtract to 0, minus x to both sides. We get x cubed minus 4x squared minus x plus 5 equals 0. And then we can go ahead and go to our menu, new document. No, we do not want to save. Go to graph, and then type in our function here. We have x, move up so you can see, x cubed, oops, delete, x cubed minus 4x squared minus x plus 5. Hit our enter button, and it'll boom give us our wonderful thing. Go to menu, analyze graph, find our zeros, and our bound's going to be between here and here. Or we can just go to trace. It'd actually probably just be easier, just trace the graph because the graph is kind of small. So our first 0, which is at x is equal to negative 1.09, Then we go to our second 0. Which is at, too far. Which is at 1.16. Our last 0. It's going. Which is at 3.93. So it doesn't really matter which way you want to use this. You can kind of do whichever way you feel you want. But we kind of get the same thing here. The intersections by doing them separately or putting it together as one and getting the zeros. It just matters like for example, the first one, method 1. Since this one was so far away from the graph to actually get all the way up to 3.93, took forever. But this one here, putting it together, you kind of get it all in one. It's just much easier to do. So, I mean, but it's your choice what you want to use.